So let's move on to the question and answer segment of today's talk. So if the studio can share the screen. We do have a number of questions that came in ahead of time, so we're going to start off with these. But for everyone listening, please do type in questions to the Q&A. We'd love to interject with some of those, but we're just going to start off with some of the ones that have come in ahead of time. You'll also see the QR code that Plinio mentioned in the top left corner, so please feel free to take the survey about perceptions of reproducibility. We'll address the first question to all of our panelists today jointly. So whoever feels like they want to start first can go right ahead. The question is, where could we find the incentive to attempt reproducing experiments when most journals and funders seek novelty?
I'm happy to have a go at that.
Please.
Okay. Yeah.
Yes,
I can't see myself for some reason, but yeah, I think that we do have to clearly address the incentive structure, because it's absolutely true that most early career scientists feel that huge pressure to get something incredibly novel. So I think a lot of it lies with the funders, and some of our funders, I think, are beginning to see the light and beginning to realize that the perpetual quest for novelty is a false one, because they put a lot of money into research programs, which then generate research which is just useless because it doesn't actually reproduce. So I know in the UK, two very positive things. One is that the Wellcome Trust, who are a massive funder in the UK, have been really on board with this whole idea that we need to focus much more on reproducibility and research quality, and they take that more into account now when they are evaluating proposals, and it's becoming more and more a feature of their their criteria. And also we now have, as head of our UK research, UKRI, I can't remember what the I stands for, but it's the overarching organization for our government funded research institutes, Ottiline Laser, who is also somebody who has particularly spoken out against the idea that everything's got to be groundbreaking. And she once very memorably said, well, if everything is groundbreaking, you just end up with a lot of holes in the ground. We should be doing good cumulative research where and not denigrating studies that don't find something desperately exciting on the first shot. So I think the funders are beginning to get it, and the funders are key because they do not want to waste their money. And so I think they are the people to really push, to point out to them the extent to which they are wasting their money if they only seek novelty.
Excellent point. What about Plinio? Would you like to add to this?
Yeah, we actually have a lot of data already stored. Dorothy mentioned this file drawer effect. Every lab at least attempt to reproduce at some level of study. So I see incentives in two ways. One is to start reproducing or replicating studies from ground up. The other one is put out what we already have. In my field, this is behavioral pharmacology. There is a lot of data that never saw the light of the day. And this is an important source. Imagine how many students validated a new model in the lab. Imagine how much data we already have there that needs to be discussed and needs to be put to peer review, et cetera, et cetera. So incentives we have already. It's a matter of what stage we are talking about.
Excellent. And what about Peter? Would you like to add?
Yeah, I want to confirm what Dorothy said. And maybe the Wellcome was the kind of leader in this field, because I was invited to a symposium by the Volkswagen Foundation. So they try to do a lot of blue sky thinking research, high risk projects, but they are thinking now along similar lines. And I found this quite reassuring. And I think Dorothy mentioned the right point, because they start thinking, we don't want to waste our money. So if there is something that could increase the standards, this might be good for the community as a whole, and it might also, in the end, raise our own profile. So I think that's a very important point. Something else, this is really funny, what Dorothy mentioned is this kind of groundbreaking. Dr. Laine was on the board of Science for a while, and I had a number of conversations with her in Cambridge. What I have seen over the last years is that people write in their cover letter very often that what they have done is paradigm shifting. And at one stage, I just couldn't resist the temptation and say, there seems to be a constant paradigm shift going on. And very often, I mean, maybe people feel this need to overhype what they have found. If you have done something solid and good and you're sure of the data, it doesn't need to be paradigm shifting. So we should probably lower the wording. But I've seen this time and again, and very often people feel compelled to use these words: groundbreaking, breakthrough, and so on.
Wonderful. Thank you. So it sounds like the kind of ships are turning, and maybe in the future we'll have an easier time also including these. And as Plinio mentioned very nicely, it's true. Most of us do have in the lab. There are kind of already replication studies done. We would just need an outlet and perhaps funding to do more of it. So actually at this point, let's take one of the questions that came through the Q&A. It's quite long, so I'm just going to shorten it to the gist of it. So it's primarily directed to Dorothy, but of course we welcome everyone to answer. It's about the concrete measures that you would most recommend to implement regarding reliability of our findings. I guess this is specifically from an early career researcher point of view.
Yeah, obviously what makes for a reliable measure will depend on what you're measuring. As a basic rule of thumb, quite often more data is what's needed. So people try and get away with quite short measures, often because they want to look at lots and lots of different things. But you basically need to do the sort of basic field work of trying stuff out. So, I mean, as an example, we at the moment are interested in brain lateralization. We're particularly interested to see, given the pandemic, whether we can get reliable measures if we use online testing of behavioral measures. And we just went about it by trying stuff out and really giving people initially very long tests and then seeing what's the minimum number of trials we can get away with without losing test-retest reliability. And we've got measures with test-retest reliability above 0.75, which is great for online testing, but we are using a lot more trials than would normally be used in this field. And this is, again, a field where very often people have no idea what the reliability of measures is. So, you know, we just had to spend quite a lot of time trying stuff out. And then one measure was unreliable and we didn't understand why. So we you know, you just had to keep tweaking it. So you're doing really the exploratory phase when you're developing your measure. But you just have, if it's not reliable, I mean, it may be that it's useful in some other ways, because if you're looking just at an overall effect of comparing two conditions, it may be that the error of measurement is not such a severe consideration. But it's mainly, if you're looking at individual differences, it's really pointless to have an unreliable measure, because you simply will miss things that are true, but you will also probably get some sort of fake result. So as a general rule, it's necessary to think about your task, and if it's not reliable, to think, why is that? Why is performance fluctuating? I know in the areas of, I don't work with animals, but I know people who do, who say that all sorts of environmental things can have massive effects on some of the things that they measure. So things like the ambient temperature may make a difference, and sort of very minor differences in procedures. So also really documenting your protocols and being very, very clear about every step of what you do is very, very important. And that's important not just within your lab, but it's even more important if you then want your same effect to be found in somebody else's lab. And I think the sort of wet lab people are beginning to recognize that they need to do those sorts of studies, because otherwise the literature becomes full of results that people don't know if they can trust, and people are trying to build drug development and things on results that are just not solid.
So what you would basically recommend is to do thorough kind of pilot experiments to really make sure that you understand what you're doing, and then document that process very clearly.
Yeah. I mean, I think so much of this pressure to do exciting, to do the next new thing, this pressure against, people say, well, it's very boring to just sort of replicate or just do the same thing, has meant that we no longer very carefully develop our methods, and so that we're really confident under what circumstances do we get this effect, and how big is it, and what are the sources of noise that we need to control. Right. And I think if funders started to be more, somebody I think in the Q&A said, shouldn't the funders be funding this sort of stuff? Well, yes, absolutely. There should be more funding for such basic development, rather than always just saying we've got to get the next amazing result, because we've been trying that for a long time, and we've just, I think, wasted a lot of time and money.
Right. And what you said also ties nicely into what Peter was telling us about the checklists.
Yeah.
So having these kind of seemingly, obvious things, but once we actually start going through them methodically, we're getting a much, much better result, and something that's actually replicable for somebody else.
Yeah, indeed.
Well. So that ties in very nicely. Plinio or Peter, would you like to add any comments, or shall we move on to the next question?
I think let's go to the next question. Dorothy has already presented this in quite accessible detail.
So just in case anyone has another tab open, I'll just read out the question, and then Peter, you can go ahead and answer. So the question is, how can we make the publication of replication studies sustainable for journals? So please continue.
Yeah, this is a big problem because at the moment I see that many journals are focusing so much on this impact factor. And impact factor is usually when you get a lot of citations in the first 2 years after your paper has come out. And I know that some of my competitors really going around and telling the world, look, this is my impact factor. And in some parts of the world, people are comparing journals and they know all the numbers by heart. I have to be very honest with you. I have no idea about my impact factor. I'm trying to go after good science, but I can see the point that is a kind of, in this competitive world, when you come with a replication study, people will immediately say, oh, well, this is not so, this is boring, why should you have it in your journal? And at the moment, I have no answer to the problem, but I can see the problem. And my personal approach until now was, I'm trying to go away from this. I'm trying to see, is there an underlying exciting science when I publish a paper? But I haven't thought about what does it mean if you replicate a study and reproduce something that is already in the public domain.
Okay, interesting. And what about Plinio as an editor of a journal specifically focusing on this? How would you comment on this?
Maybe Plinio, this could be a niche for you.
Yeah, from my perspective, I think the main way to make it sustainable is having digital institutional infrastructure. So when the institutions step in and they are responsible to archive, to maintenance, and to take care of that, this is a big step forward, because then we no longer have to care about novelty, about the impact factor. So once you have public money diverted to the preservation of these data, then we can operate a journal that is perfectly viable in this scenario. Of course, there are costs involved. There are other ways to find sources, but let's remember, the immense majority of work is already done for free. We make the papers, we collect the data, we write them, we revise them. So this is already a big process that is already funded, publicly funded. We just go a step forward, and on that, engaging librarians, engaging institutions to make the repositories and to maintain that repositories. This is a big step forward to help making this a sustainable model, especially for diamond open access.
So of course, while we're waiting for these more institutionally directed programs to come, we do still also have commercial journals. And I guess one of the questions kind of related to this is how this could be made more sustainable for them. And I think Peter already partially answered this, is that it comes with, is it exciting science? Then, you know, that kind of organically grows into it. And what about Dorothy? Would you like to add anything to what's been said here?
Only that obviously replication is extremely uninteresting if the science is settled. I mean, if we all accept that we already know something, you don't want to find it out again. And I think the problem is that we've got into the mindset that once one paper shows something in a journal, it's settled and we can move on. This is just so untrue. I mean, science has to be cumulative. And so I tend not to believe things on the basis of one paper. My attitude is not dissimilar to that you see in clinical trials. I mean, clinical trials, as we see at the moment with trials of various drugs, you need a whole set of studies really before your level of confidence gets to the point that you really think we know what the answer is. And I think if we started to think about science more that way, we would see that replications are key, because they are the one things that allow us to decide what is credible, what is, you know, what can we move forward on, rather than you know, just falsely build. I feel a lot of the time we try and falsely build on things that haven't yet been sufficiently corroborated.
Very true. Let's take a question from the Q&A. So it's actually several long questions related to statistics. Rather than reading them all out loud, because we're still going to be here tomorrow, I'm going to try and condense them into kind of the key point that we'd like to hear your thoughts on. So the idea is that very often authors, we might either have limited knowledge or limited confidence in the use of different kinds of statistical tools. So what would your kind of suggestions be for alternatives in improving the education of statistics in science, perhaps starting from the early career point of view, but also going all the way through the career lineage, because this is something that affects everybody.
Mm-hmm. Well, I'm happy to comment on that. I mean, I find statistics is really tough, and I like statistics, and I'm continually finding I'm running to keep up because it keeps changing, it gets more complicated, more new methods come in, and I enjoy trying to learn about things, but I'm getting to the point I think my brain is full. But there's two things I would recommend. One is, if you want to learn about statistics, I would say we should be teaching people using data simulation, which is now very easy to do. And that's the way I feel I really understand something, is if I can simulate some data and run an analysis and see how changing features in my simulation influences how that analysis comes out. So I would say turning away from the sort of classic ways of learning by a sort of clicking, you know, from a menu. You have to get people into languages like R, where you can simulate data and then see what happens. And that forces you also to think about, if you have to simulate a data set, what's it going to be like? But the other thing is we need more statisticians. I work with somebody who trained as a statistician, who I'm very glad I took on to my research group. And I didn't realize until I took him on how much I thought I knew but didn't know, and how very useful it is having a properly trained statistician to look at your research and advise on methods and so on. We have far too few of these people. Again, the medics are quite lucky because often they do have medical statisticians to advise them, whereas in so many other areas of science, we're somehow expected to learn to do all that stuff on top of all the other things we do. I think we need to know enough to have some idea that we can have a sensible conversation with statisticians, but I think we should be training far, far more statisticians, and they should routinely be part of various academic departments and taken seriously.
So also having enough knowledge on stats so that we know when we don't know the answer.
Yeah, exactly, which I'm shocked to find. Sometimes I thought I knew the answer and then I find I don't.
And I think this is also where the statisticians in the review process comes in. Of course, that's at a very late stage of the process. So if we did the stats poorly to begin with, there's only so much a statistical reviewer can tell us. But perhaps Peter or Plinio would like to comment on the aspect of stats reviewers. We've had several questions about that in the Q&A as well.
Yeah, I think what is really important, Dorothy mentioned we need a lot more statisticians. And I think we need to have a higher profile. Statisticians need a higher profile. So for a long time, this was considered to be, oh, this is some kind of dull profession. Number crunching. And people just didn't understand that very often it is these kind of professions that are so important to processes. For many years, not only in the field of science, but we were always focusing on the kind of glamorous end of things. And the glamorous end of things needs a very broad underpinning that people very often neglect. In a more specific way, very often people come to me at an early stage, as it's a so-called pre-submission inquiry, before they have even submitted a paper, and they ask me, do you think this is an interesting finding? Do you think we should continue in this direction? And at that stage, I very often ask them, did you consult with a statistician? Do you know how many separate experiments you really need to do? How many animals do you need? And so on and so on. Because people have found something, 1 or 2 cases, and they think, oh, exciting, let's go for it. So I'm trying to introduce this thinking that we need statistics from a much earlier stage. I mentioned our statisticians on the board and the statisticians in the review process, but this is what I would say at the end of the process. But we should have incorporated it, and this is probably something where we need to change the overall perception in the field, and in most scientific fields, to move this forward to a much earlier stage when people come up with an idea, start right from the beginning. How many experiments will I need? What needs to be tested, instead of just doing one exciting experiment, get a result and say, oh, this is cool stuff.
I think part of the, sorry, just to say, part of the problem as well is there's no career structure for these statisticians. That is something, again, we could fix, because they don't quite fit into the regular academic career structure, because they're not doing groundbreaking research. But they're vital to all of the rest of us.
Building the ground back up again where we made lots of holes in it.
Yes.
Do we move to the next slide, because the next question is actually relevant, and Plinio, you can continue with the thought, because I'm sure it would relate to this as well. So I can just read out the question. So this is about registered reports, which kind of deals with something that Peter alluded to in his previous answers. So what are your thoughts about the registered reports publication format as an aid for replicable research? Maybe Plinio would like to start with this.
Depending on the field, I would say, because especially for biochemistry, where there's a lot of in vitro experiments, it's unviable, and it's frequently data-driven. But depending on the field, they are more than welcome, of course, and I think they can help a lot.
Okay. And what about Peter? I think this is related to what you were mentioning before about perhaps even at an earlier stage, considering the questions that that you were talking about. So what are your thoughts about this format?
Yeah, I mean, Plinio hits the nail on the head. It really depends on the fields. But again, just looking at the development in the fields that I've seen, a number of years people were mentioning it, in particular in the cover letter, for example, that this is, for example, a pre-registered set of experiments as being something special. And I noticed over the years that this has become now the new standard, for example, in psychology. So I think that we are going in the right direction. But I can, of course, see that in the field of biochemistry or whatever, there will be different stumbling blocks in the way. I'm not sure we can put them all in one big drawer. It really depends. It's field specific.
Can I just say, I think registered reports is more than pre-registration. So I think pre-registration is great. But with the registered report, you get your protocol peer reviewed before you collect the data, and accepted in principle if it's deemed to be methodologically strong. And I think it's a fabulous format. I am one of the first people to have done one and to have published one, and I try with all our big studies to turn them into registered reports, which is really hard. But my goodness, it makes you think incredibly hard about your study before you embark on it, because you really have to have every detail thought through as to how things might work out. And I think my work is better for it. It completely gets round publication bias and p-hacking and harking. You are required to have a decent level of statistical power. But the most important thing is you get the referee comments at a point when you can use them before you've actually conducted your study. So I can benefit hugely from getting feedback at a point when I can then take into account what the reviewers say, rather than having reviewers saying after the event that it would have been much nicer if I'd done X rather than Y.
Right. Thank you. Very interesting answers. We are very much reaching the end, but we're going to take one more question with quick answers. So could I have the next slide, please? Adrian or someone from the students? There we go. So quick opinions on this question. Should PhD students have to perform one replication study as a requirement for their degree? Who wants to start?
I can start on that.
Please.
No. We are already talking about overworked class. So I would say it's important that labs should start to use that, start to require to do more replication, but not keen on the backs of PhD students.
Fair enough. What about Dorothy? What's your opinion?
I don't like to make things mandatory. I think, you know, that would be crazy. Getting too regimented. But I think it can be a good thing to do. But of course, it depends on the area you work in. I mean, in my area, some of the studies we do take 3 years to do. So, you know, this would not be feasible. But I think there's a lot of value in trying to replicate something before you go off. And for example, the big problem is PhD students who start trying to build on something and take it further without first replicating it, and then realizing that they can't get the result. That happens over and over again. So I think it's a useful thing if you've decided you're going to follow up on a particular line of research to first show that you can get the effect that the previous people got, because of all the forces that conspire to make things non-replicable. You may otherwise find you're building your house on sand. Great
point. And finally, Peter, any last thoughts about this?
Yeah, it's fascinating. That brings me back to my time as an active researcher. In these days, we didn't use the word replication study, but it was obvious. You would try to reproduce something that is in the literature just to make sure that you understand the system you're using. And once you were confident, then you would go on and build and do something on top. So I think that in a way, replication is inbuilt in the scientific system. You don't always start from scratch, or you don't take everything that is in the literature as the word of God that you can build on, but you constantly reproduce things. I remember how much time I spent going through the methods parts of papers, trying to see how did they do it, and do I have to follow all the protocols in detail. So I think it's part of the scientific process, and so I don't think we need to require this from PhD students.
Excellent point.
If someone is serious about their experiments, it will automatically be done.
Right. Fantastic. We could, of course, go on for hours and hours, but we do have to call it a day for the rest of the program. Thank you so much for attending and for taking the time to answer all the questions. Please go and fill in the survey. Also, if anyone has any specific questions for Plinio, he is going to be at the poster session talking about this. And I guess the most important thing we can do is just keep talking about these things, keep reproducibility at the top of our minds, and hopefully these things will start to get a lot better. So thank you for my part, and have a great rest of the day, everybody.
Thank you for inviting me. Thanks.
Yeah. Thanks much. Bye.